So, hello, hello everyone, welcome back to the channel. So, today we will be taking a look at this question called the extreme subtraction from the Codeforces Division 1 round, which was held long back ago. So, I definitely, as always, recommend you to try this problem on your own. It is really good problem, I would say. And yes, here we go. You are given an array A of n positive integers. So there are timestamps in the below the video or in the description. You can skip to the solution part if you have already tried this problem. So you are given an array A of n positive integers. So you can use the following operation as many times as you like. Select any integer 1 less than or equal to k less than or equal to n and do one of two things. So decrement by 1 the first k of the elements, so k of the first elements of the array, or decrement by 1 k of the last elements of the array. I wish there would have been comma here. I think there would have been comma here. There should have been comma here. Okay. Anyways, so for example, if n is equal to 5 and a is equal to this array, then you can apply one of the following operations to it. Not all possible options are listed below. Okay, nice. So if you decrement from the first two elements of the array, so you are choosing k is equal to 2 and your decrement is 3 to get to 2 and this 2 to get to 1, so it will be 2 1 and remaining of the array will remain same. You can go over these two examples as well. So we have to determine if it is possible to make all the elements of the array equal to 0 by applying a certain number of operations. Okay, and our constraints are like t is going up to 30,000 and n is going up to 30,000 as well, and sum of n over all test cases doesn't exceed 3 o 3 30,000. Okay, anyways, so yes, and our array elements are from 1 to 10 to the power of 6. So let us take a look at these sample test cases. So hello, and so I think it should be somewhat bigger. Yes, so 11. So let us suppose 11 is here, 7. So suppose 10, 9. Okay, why always? Okay, so this is 11, this is 10, this is 9, let's say 8, 7, 6, 5 and so on up to, okay, let's draw it, 3, 2, 1 and 0. So suppose the first element is here, second is here, third is here, fourth is here and fifth is here. So first element is equal to 11, so it's here. Second element is equal to 7, so that is 8, 7, 6, 5. So 7 is right here. And what about 9? 9 is here, 6 is here, and what about 8? Right here. So our graph is somewhat like, if we consider it as a graph, so it is something like this, right? Okay, so what I am doing is that I am choosing the first k elements and decrementing it, or I am choosing some of the k elements from the last and I am decrementing it by 1. Okay, makes sense. So what type of a generic graph fits these conditions? So it will be something like this. So let's make it green. Okay. Or let's say this type of a graph. Okay, so what I'm trying to say is that, so it is decreasing till a certain point, not strictly decreasing. I'm saying decrease. Okay, non-increasing. Okay, non-increasing. It is non-increasing till a certain point from the start, and it is non-decreasing from that same point. Or you can say it could have been something like this as well, but from here it is non-decreasing, and till here it is non-increasing. Okay, makes sense. So what will I do to make this whole thing to zero, to make it down to zero? So I will perform k operation. So I can basically select this k. So this k till this part, the lowest part, gets to the zero. Okay, once it gets to zero, I'll reduce my k to this point. Okay, when this gets to zero, this will also get to zero, and I'll reduce my k till this point. And when this gets to zero, this also gets to zero, and I'll just decrement my first element to the zero. Okay, and same part on the right, so nothing more complicated. So my graph should look like something like this, right? So finally I have to convert every graph from any type of the graph to this graph. If it is possible, then I'm good to go. Okay, so, and what I don't want to make my graph look like is something like, suppose it is decreasing till a point, and then it is okay, it is non-increasing till a point, and then it is increasing, and it drops down and then increase. This I don't want to what you can say, I don't want to keep in my graph, right? So what I will do to tackle this is that, so let's suppose this is one element, this is second, this is third, this is fourth, this is fifth, sixth, seventh, and eighth, let's say. So I want to make it non-decreasing in this part, right? So my this part is okay. I don't I'm not really bothered about this part. The thing I'm bothered about is this part, the right half, or not even a half, but the right part of my graph. So what I will try to do is that, so I will choose my k. I will choose my k from here. Okay, let's be consistent. Like from here to right up to here. Okay, so my this part of the graph, my this part of the graph will remain as it is, but my this part of the graph, my this part of the graph will shift downwards, will drift downwards, so whatever you want to say it. So let's suppose it comes downward. Okay, so let me see, I can simulate this or not. I think I can. So this part will go down like this till here. So we want to make this element, so this element is also drifting downwards. Oh, okay. So so this element is also drifting downwards, right? So it will come right down till here. Okay, and my joining part will be something like this now, and this will get deleted, and this edge will be formed, right? Like this. So my graph is following my criteria. Okay, so I am good to go. So but But what I am caring about is that, so I took this part down, right? So I took this whole part down by some units, right? To bridge the gap, to bridge the gap that was here, right? So like this it was there, right? So I took it down till this units, right? This units. But what about this point? So one thing you can notice here is that, so if you are making that point go down, so you are making this point go down, then it won't go up again. There is no such operation at our disposal. So if this value gets less than 0, if this value right here gets less than 0, then we are doomed. We are doomed. We have nothing to do, right? So at the same time, while decreasing this, I want to take care about this part not reaching below 0. So this I don't want to happen. I'm okay with this happening 0, but not less than 0. Okay, so that is basically the whole idea of this solution. So what I will do here is that, so let us take a look at this sample test case. So whenever you see a dip, okay, so dip from the, or you can say decreasing part, so I will try to remove this part and get it to like this. Make sense? So basically I will drift all this part down. So with that, this edge will also get like this straight. Okay, so let me do that. Let me do that quickly. So let us be strict with the quantities of the element as well. So here it is 9, here it's 6, so you are getting a dip of 3. So it will go right till the 4, it will go right till the 8, and this will go right till here. So my graph will look like, my new graph will look like this right in the green. Okay, this right in the green. Now once I have this kind of graph, then my life becomes simple, right? So I'll choose this k. Okay, so I'll choose this k till this part reaches to 0, and whenever it reaches to 0, I'll just choose k is equal to 1, get this part down to 0, and starting from end now I'll choose k is equal to something like this. And okay, not this, because this element is already grounded to 0, so somewhere around this, and I will keep taking that k until this part reaches down or dies down to 0. And yes, well, and then I'll shift my k to this part until this part dies off, and then I'll do k is equal to 1 from the end, and I'm basically good. I'm good to go. I can convert that to a 0 sequence. Makes sense? And yes, so when can I not convert it to the 0 sequence? So let us take a look at this test case. So good enough, okay, big enough. So this is 3, this is 2, this is 1, this is 0, and that's -1. Okay, -1, not 1, 2, 3. Okay, so so uh, our first point, let it be here, this is second, third, fourth, fifth. So first point is here, right here, third second is here, third is here again, fourth is 3, and fifth is 1. So my graph is looking something like this. Okay, makes sense. So uh, yes, so I start traveling from the first index and I see a dip. I see a decreasing sequence, strictly decreasing sequence. So what is this gap? That is 2. What is this gap? So this gap, that is 2. But Can I take this element down by 2? Can I take this element down by 2? Absolutely not. It will reach to minus 1, which is less than 0. Okay, so in this case, answer will be no. A big red no. Okay, that's black anyways. So that's the thing. And that's why answer for this test case is no. And one more thing to notice here is that, so your graph is suppose something like, oh, okay, let it be like this and this and this, maybe a bigger line. I would say my free drawing is really bad. Suppose a big dip here and like this. Uh, so whenever I see a dip here, so whenever I see a dip here, I want to neutralize it. So I'll take this whole part down to this level. Okay, so this part, okay, and it will come down. So it will basically be becoming something like this. So this is our first step. Let me label it. First step, go taking this down. So again, I want to tackle this dip as well. So to tackle this dip, I want to take this whole part, because I cannot skip the elements, right? I want to choose k elements from the first. I cannot skip any of the element. So I will take this whole part down. So let us take that part down, so it will become something like this. Okay, so this will come down like this, then this, then this. Okay, so what I can notice is that, so to tackle this dip, okay, so to tackle this dip, my this point went down. Okay, my this point went down. Okay, so what about this dip? This is a really big what you can say difference, right? So to tackle this, I want to perform the operation from right here, right? So from the left part I have to the left part I have to do the operation upon. Okay, makes sense. So when I do that operation, my this point, the minimum what I'm having is also decreasing by this point. Notice that this point will also go down by, suppose this height is h, suppose this height is h, so let me make it permanent. This height is h, so my this point will also go down by h, but I don't really bother about that point going down h, right? So I do bother, but what I bother more about is the position of this point after it descends down the distance h. Because if this becomes the red flag for my graph, is if this becomes the red flag for my graph, then I don't even care for this thing, right? So this part is both necessary and sufficient. So this thing going down below the zero, this part is both necessary and sufficient. I don't care about this node if this node goes to less than 0, right? So it is both necessary and sufficient condition for my answer to become no. Okay, so what I will do is that I will iterate from starting, and whenever there is a dip, I will descend down. I will descend down the minimum element. I will descend down the minimum element by that dip. Okay, so my minimum element is mini. I will decrement it, minus is equal to the dip or edge, you can say. Okay, so the edge, and if this mini becomes 0, if this mini becomes, oh okay, mini becomes less than 0, then you are doomed. Then you are, oh, doomed. Okay, so but if it doesn't, then you have to also take care of this thing, right? So this can also become your new mini. Notice this can also become your new mini. Can you sensing that? This can also become your new mini, because suppose this sequence was high up like this, so something like this and this. Okay, so this and this, so this is incrementing part. Now my minimum is this. Now my minimum is this, but okay, wait, not exactly like that actually. So when I'm having a, okay, so for the first dip only, my minimum will change, my mini will change through this point, right? So till here, so you will start with the second index because you are okay with this dip, right? So not with the first index, you are okay with this dip to happen, so you will start with the second index, and check. So till then your mini is like something here, mini is something like here. But when you decrement it, when you decrement this portion, okay, this portion down to this height, then your mini is changing, right? Then your mini is changing here. So that's basically the thing, you have to take care of that as well. So I hope that is basically the whole solution for the problem. I hope you understood it. Let us head towards the code. So uh so prefix minimum is really not required here. I don't know why I calculated that. Okay, I know, but it was the part of my previous solution, I believe, but that didn't work, I think. So yes, it is not required, you can comment that out. And yes, taking the input and initializing while bool, which is possible, is equal to true, and initializing mini is equal to v of 1 and starting from 2. And remember, why are we starting from 2? Because we want to ignore, this initial height difference. So initial dip, we want to ignore this part, right? So ignore this part right here. That's why we are starting from the 2. Okay, so yes, and whenever there's a dip, uh, if that part is greater than minimum, so our dip should be less than or equal to minimum, otherwise it will go below 0. So it, in that case, possible will be false, and we will break down the for loop and directly head to the outputting the things. And minimum minus is equal, so that is basically the dip that minimum will be bearing on its head. Okay, so and finally minimum mini is equal to minimum of mini comma v of I. So that is basically discussing the solution. So for this part, right? So for this part, that second statement is there, so this statement right here. So that is why that second thing, mini is equal to min of mini comma v of I is there. And yes, so if it is possible to make the sequence of the elements 0, you are basically outputting yes, otherwise no. So yes, thank you for watching the video, and hope you enjoyed solving the problem and listening to the solution as well. And if you really enjoyed the video, consider liking it and staying tuned, staying subscribed to the channel. And yes, thank you again.